All right, today is lesson 96. This should be your lesson for Thursday, March 19th. Your homework is practice set and all questions. All right, so you have all spring break to do that. Just want to make sure you guys are getting a good dose of review in with hitting each question. So again, make sure you're keeping all these homeworks organized, that you're grading them on your own with the answers that are posted online, and that you are keeping them either in a folder or binder, something that you can turn in as a homework portfolio for all the days that we've been doing our distance learning. All right. So today is lesson 96. We're doing geometric measures with radicals, and I think that this is a good opportunity for us to do a little bit of like term review before we get into the crux of this lesson. So let's start with that. All right. So here we go. Try to pause these or do these on your own as we go through them. All right. Again, it's all review, so you should know this. So x plus x equals 2x. I'll just write them all up here, and you guys fill in the answers. All right. So that's how I've done it when we were in class. So I'll let you guys answer these as I go. I'll give you the answers at the end. All right. So hopefully you've had some time. If not, pause it here, go through and answer these in your notebook. 6, 7, 8, 9, and 10 are going to be the majority of today's lesson. All right. Over here we should have just a healthy dose of review. So number 1, x plus x equals 2x. Number 2, x plus x squared. Now, I don't have any like terms, so I can't do anything. It stays x squared plus x. Again, I have to write that in standard form, so it goes with the highest order exponent first. So x plus x squared would be wrong on a test. 3x plus x, both like terms, so I can combine. The only thing that changes when I'm adding like terms is the number in front. So that would be 4x. 5y squared plus 5x plus y squared. The only thing that's like here are the y squareds. So 5y squared plus 1y squared is 6y squared plus 5x. Again, have to write the highest term first, highest ordered term first. All right, over here, a long one. So I'm gonna go ahead and underline all the like terms. So I'm looking for x cubes. All right, so I get one right here. So those are like, I can combine those. I'm gonna go through and do 2 lines for all the x squareds. So that would be right here. And that leaves 2x by itself. So add the one-liners. 8x cubed plus 1x cubed is going to be 9x cubed 2x squared plus 3x squared is going to be 5x squared. And then that leaves plus 2x on its own. Again, descending order. Must be in descending order. All right. So these same rules apply over here, okay? In order to add radicals, I need to have the same number inside the radical, all right? So root 2 plus root 2 is the same as x plus x. The only thing that's going to change when I add radicals is going to be the number outside the radical. So I could say that this is 1 root 2 plus 1 root 2, which would get me 2 root 2. I have 2 root 2's. So again, I have to have the same number inside the radical to add. So I have root 3 and root 3 here, so I can add these. These are like terms. The only number that changes when I'm adding like terms is the number on the outside. So it's going to be 7 root 3. Here, different number inside the like terms, I can't add them. So it would be root 2 plus root 3. I don't believe there's any real standard form for that. Okay, so you can write that either way. All right, going down here. Got to be careful. The only thing that I have inside that's common is the root 5's here. So that would be 8 root 5 plus 5 root 3. Sorry, running out of room. All right, down here. 1 root 7 plus 6 root 7. They all got root 7s, so they're all like, kind of just a little tricky here. This is the same as 1 root 7. So this is going to get you 8 root 7. All right, so if we know this, we'll be good on this lesson. They try to make it a little bit harder with some of the problems, but as long as you know that you can add radicals that have the same number inside the radical, you're in good shape. All right. So let's look at a couple problems that they're going to do, that they're going to throw at you. All right, so the first one is they're going to give you shapes, right? And try to ask you to find the area and perimeter, okay? So if I have a square whose sides are all root 2, they're going to ask for both the area. What is the area? And what is the perimeter? Okay, so my area is going to be root 2 times root 2, base times height. All right, root 2 times root 2 is just going to be root 2 squared, which is just 2. Okay, my perimeter is going to be root 2 plus root 2 plus root 2 plus root 2. So I have 4 root 2's that I'm adding together. That's just 4 root 2. All right, so that's one of the problems that you'll see. Next, a little trickier. All right, let's try to get fancy with this. See how we do. Make a coordinate plane. I don't want white. And black. All right. All right, coordinate plane here, like this. Okay, so they're going to say graph the following points and then find the area and the perimeter of the rectangle the 4 points make. So your points are 0, 2, 2, 4, 3, -1, and 5, 1. All right, so go ahead and graph this and see if you can figure out what the area and perimeter is. All right, so I pause it here. Here we go. Let's graph. 0, 2. All right, so 0 and 2 is going to be right here. All right, 2, 4. 1, 2, 1, 2, 3, 4 is here. 3, negative 1 is going to be here. And 5, 1 is going to be 1, 2, 3, 4, 5, 1 here. Hopefully this works. And I can do this and this. We'll go blue. Nice. Okay. Wow. Digging this board. All right. So we need to find the area and perimeter. Okay. Start with the area. All right, so in order to find the area, I need to know the side lengths of this rectangle. So we've seen some of these before in some of our homeworks. I'm going to do that by using the Pythagorean theorem. So I'm going to make some right triangles. We'll go green to illustrate this. All right, from here to here, I can find that this is 1, 2, 3, and this is 1, 2, 3. So this is 3, 3, right? And then I know that the hypotenuse would be 3 squared plus 3 squared equals x squared. So that would be the square root of 18, okay? Sorry. All right, so to find x here, 3 squared plus 3 squared equals x squared. So 9 plus 9 equals x squared. I could also say, hey, this is a 45, 45, 90. So it's going to be 18 equals x squared, right? X equals the square root of 18. And so x equals 3 root 2. All right, so this side right here is 3 root 2. So is this side, right? It's a rectangle. All right, so now let's find the other side. We'll go red. So let's find here to here. Okay. So I know that this is 2 and this is 2. So 45, 45, 90, right? 2, 2, 1, 1, root 2. So this is going to be 2 root 2. And this will be 2 root 2. All right, so to find the area, back to our original problem, I'm going to do the area equals 3 root 2 times 2 root 2. All right, so I'm going to multiply the numbers outside. So that's 3 times 2 times root 2 times root 2. All right, which is going to get me 6 root 4. And root 4 is equal to 2, so 6 times 2. So my area here is 12. Okay, realize I may have gone a little fast there. So again, multiplying these numbers, I'm going to multiply the outside numbers, and I'm going to multiply the inside numbers. So 3 times 2 is 6. Root 2 times root 2 is root 4. Root 4 is equal to 2. 6 times 2 is 12. Okay, so there's my area. Perimeter, I'm just going to add those up. Those side lengths up. All right, so perimeter will equal 3 root 2 plus 2 root 2 plus 3 root 2 plus 2 root 2. Again, here's why we needed to review like terms. So they all are root 2's, so I can add all the numbers on the outside. 3 plus 2 plus 3 plus 2 is going to get me 10 root 2 for my perimeter. All right. We'll do one more. Here we go. All right. So if I am told that I have a triangle, I can do this. All right. If I have a triangle whose side lengths are root 21 and 2, what is the perimeter is the perimeter? Okay, so again, in order to find the perimeter, I need to know all sides. So I need to find x here. So we're going to do the Pythagorean theorem, okay, and say root 21 squared plus 2 squared equals x squared. Root 21 squared is 21. 2 squared is 4. So 21 plus 4 equals x squared. X squared equals 25. Square root of both sides. X equals 5. Again, we've gone over that this should be 2 answers here, but I know that the negative answer won't work because it's a side length. So we know that x equals 5 here, so I can now find the perimeter. It's going to be 5 plus 2 plus root 21. So that's just 7 plus root 21. Okay, and I'm just going to leave my answer like that. Are these like terms? No, because I don't have a root 21 here, so I can't add. So I just leave it as this, 7 plus root 21. All right, fellas, good luck. Practice set all questions. I hope you guys enjoy your spring break. Again, feel free to email, join YouTube Live if that's still going on at this point. And let me know if you have any questions.